Good morning, good afternoon, or good evening, depending on where you are, and welcome to the LNOS Group webinar on the Indium High Efficiency FM transmitter series from 150 watts to 60 kilowatts. I'm your host, Chuck Kelly, with the LNOS Group, and I'm joined by two very, very special guests, very knowledgeable people here who are going to lend their experience to this webinar. First and foremost, Mr. Antonello Giovannelli. Antonello, welcome. Are you there, Antonello? I'm assuming you're there, but muted. And my other special guest is Mr. Peter Conlon. Peter, are you there?
I'm here, Chuck, and happy to be here with you.
Glad to have you. All right, so here's what we're going to talk about today. We're going to introduce the Indium family, and then we're going to ask a $1 million question. I'm going to let you wonder what that $1 million question is. And then we're going to talk about the design of the RF amplifiers in the Indium series and the technical innovations in those designs. So one of the common themes you're going to hear in this webinar is the word innovation, because this transmitter series, and in fact our group, is all about innovation. We're going to talk about the innovations that we did in the development process, in order to maximize efficiency. And the innovation, believe it or not, in the power supply, the innovation in the power supply, and the direct-to-channel FM digital exciter innovation, and the robustness in the innovation. What gives the LNOS Group ETG series of transmitters the reputation of having the most robust and reliable transmitters in the market? I'm hearing some background noise there, folks. Need to have you stop that, whatever it is. Remote control, innovation, and live demo. And then finally, we're going to ask your questions. Now, you'll notice in the webinar, GoToWebinar interface that you've installed on your PC, that there's a place that has a place to enter in questions. And please do mute. That's a good idea. But there's a place to ask questions, and please do enter in your questions there. And at the end of the webinar, we'll answer all of your questions. Remember, watching this webinar qualifies for a half a credit towards the SBE certification under Category 1. And you should be able to use those points towards your recertification. And we're very proud to be associated with the Society of Broadcast Engineers. All right, so the Indium family of solid-state FM transmitters are available from 150 watts to 60 kilowatts. They're scalable and flexible, and they're available with direct-to-channel digital exciters or analog exciters. They're optimized for efficiency and robustness under real-world conditions. They've been designed with 42 years of experience, and I should mention that the LNOS Group has about 60,000 transmitters in the field. So we know what we're doing here. And you can monitor and control them from anywhere through a very sophisticated web interface. And as well, you can use SMS or you can use SNMP, as some people want to do these days. So here's the $1 million question. And Peter, I'm going to aim this at you. You and I have worked together at Nautel for a number of years. You were the president, CEO of Nautel. And you're over there in Italy now at the LNOS headquarters in Ferrara. My question to you is this. In prior years, we looked at LNOS and we're pretty amazed with the quality and the efficiency and the performance and the robustness of the transmitters, but we're surprised always, I think, or mystified, perhaps is a better word, as to how in the world they were able to do it so cost effectively. Can you help explain how these transmitters can be built so inexpensively?
I'd be happy to, Chuck. Thanks for the question, because you're right. We scratched our head back in the olden days. I think it starts at the beginning with the founder, with Leonardo Busi, because he is an amazing mix of technologist, visionary, entrepreneur, and he absolutely loves the broadcast industry. And what he recognized was that Italian transmitter manufacturers had a reputation in the world for perhaps not exactly having the finest products, What he said is that LNOS would build the anti-Italian transmitter or the antithesis, and that they would use innovation and technology to design the most robust, reliable piece of product that would come out of this country. And then he had the nerve to go ahead and say, and we're going to build lots of these so that we can make them for the best price possible and people will come and buy them. And he was right. So now you have and when you see the things that are in this transmitter that Antonello will tell you about, that lend to robustness, creativity, management, and control, you're going to see why there are 60,000 LNOS Group transmitters in the world.
That's amazing. Okay, so it's primarily due to quantity. I mean, there's just so many of these things going out the door, and the design is so well done that they just are less expensive to build.
And they keep on ticking.
Yep. Okay. Thank you for answering that question. I've been wondering that for many years. So, Antonello, are you with us now?
Yes, I'm here.
Okay, great. I want to talk about the innovation that's a part of the design of these transmitters. We use strip line or microstrip techniques, also known as, well, you tell me, it's a planar technology, right?
Yes, the design was developed using microstrip and strip line transmission lines in order to avoid cables, connection, soldering points, and so on, for the best efficiency, repeatability, and ease of maintenance.
And these terms, strip line, microstrip, planar technology, all refer to the fact that the inductors, some of the capacitors, the transformers in many cases are all part of the circuit board itself.
Yes, it's correct. All the components, most of the components, as well as transformers, inductors, capacitors, and transmission lines, are realized inside the board.
That's excellent. And so therefore we have to use some pretty specialized PC board material in order to keep the performance optimum.
Yes, of course. The boards are in special materials useful for microwaves, for very, very low losses and high performance.
Thank you. Let's talk about thermal modeling. This is something that I've never seen looked at in this fashion. Some manufacturers will just look at a design and say, well, did it get too hot? No, okay, then we're okay and move forward. But we actually do a lot of development and modeling of the thermal design to maximize performance.
Yes, the design was made using thermal simulators in order to obtain the maximum efficiency from the heatsinks and in order to minimize the size.
And there's another thing too, and that is that you and I both agree that the PA device particularly will have much less life as the device is operated at a higher temperature. So keeping those devices cool actually leads to the longer life of the transmitter.
Yes, low temperatures means high life, long life. So all the design was oriented to reduce in each point the temperature.
Excellent. Okay, let's press on. All right. So one of the things that you've done in order to improve efficiency is you've utilized Class F PA design. So I think most of the broadcast engineers that I'm familiar with know what Class A and Class AB and Class C is. Maybe they know about Class D and perhaps even Class E. But what is Class F and why do we use it in the transmitters?
Yes, Class F is typical design of a push-pull radio frequency circuit. And Class F uses the harmonics in order to modify the voltage and current waveform at the drain of the MOSFET in order to have the best efficiency possible. More or less, in this case, with BF178, that is an LDMOS, to have an efficiency of around more or less 84-85%.
Now that's an RF efficiency, so that's DC to RF. Is that correct?
That's correct. DC
Okay.
to RF.
That's great. So when you have, the more efficient the amplifier is, in this case class F, it keeps the amount of heat generated within those solid state devices, those LDMOS devices, is reduced, which again leads to longer life.
Yes, it's correct. It's correct.
Okay.
Low temperature, long life.
I agree. All right, so let's talk about the way that we've developed the combiners. These are precision designed and carefully milled, and they are amazing to look at. They look like a very high-end product there.
Yes, amazing look, high precision, very high precision mechanics in order to have the maximum repeatability of the performances and to minimize the losses.
Yep. Okay. Very good. Thank you. All right. So now there's a very interesting feature that I think is pretty unique. I'm not familiar with this in any other transmitters myself, but there's a built-in power level scheduler. It occurred to the folks at LNOS that there are broadcasters who don't want to run the same amount of power in the middle of the night when they have a fraction of the number of listeners. So they're wanting to automatically turn down the power of the transmitter in certain hours on certain days, either due to the fact that there's less listeners or due to the fact that the power company is charging them more money per kilowatt hour during peak times. So they can make intelligent business decisions with this scheduler and calculate the energy savings that are a part of this. This is a very, we'll look at it in the user interface, but it's a very impressive section of this transmitter, something that's very cool.
Yes, you can choose a certain profile to automatically adjust the power according to the real need to irrigate a high power or a lower power.
Excellent. I should mention that in some countries in the world, power reduction, intentional power reduction, is not permitted under the government regulation. So you need to check and find out to what extent this functionality can be useful in your country.
Okay.
Power supplies. Now, most people think of power supplies as a pretty boring subject, but in fact, there's a lot of interest here, and a lot of effort has gone into the LNOS design. You may recognize this power supply if you've got a transmitter made by many of our esteemed competitors. Many of them use the same kind of off-the-shelf power supply, and those power supplies are often designed for computer clean room environments. That means the power is great, and it has a UPS in front of it, and there's a computer cleaner, so it's cool and it's clean, and they are sealed and they're not user repairable. Schematic diagrams can't be gotten. And if one fails, you throw it away. Even if it's just a 10-cent component inside, you'd have to replace the entire unit. So realizing that that's not the environment that broadcast transmitters are used in, it's not a real world environment, LNOS put a lot of time and effort into designing its transmitters for real world transmitter room environments, which include less than perfect AC and harsh physical conditions. Antonello, tell me more about this, will you?
Yes, yes, it's correct. The need for a transmitter, for a power supply designed for a transmitter, is to have a wide input AC range, needs to work with dust, with high temperatures, without faults. And the goal for this power supply was to realize a device with a very low fault range. And another goal was to realize a device perfectly matching the need of the transmitter.
Yep. And in fact, these are user serviceable. So if there's a 10-cent component that fails within it, likely you can go in and change that component yourself and be back on the air in an hour rather than waiting for the new power supply to be delivered. That's wonderful. A lot of people around the world will find that to be a huge advantage. It's also a smart power supply. It communicates with the rest of the transmitter, doesn't it?
Yes, yes. This power supply is smart. It can communicate all the variables of its working with the transmitter. So temperatures, currents, efficiency, faults can be read through the transmitter interface.
And one of the things that jumps out at me here is that the mains voltage you can read. And most of the transmitters that I've seen, the mains voltage is not something that's directly measured nor accessible to the user interface. And this one, you can actually see what the main voltage at your site is.
Yes, with this power supply, we can know, we can understand if the mains voltage is a correct value or is too high, or if we have short interruptions and so on. The power supply can work with a wide range of input voltage, from 100 volts up to 270 volts without fault.
That's great. That's great. Makes a huge difference. It, more than having a power supply that's serviceable, it's better that it never fails from the beginning.
Yes, it's serviceable, it's repairable, no critical components in the design, availability of schematics, and so on.
Yep. Okay. And each power supply is addressable. It's, for instance, in some of the transmitters, there's 3 or 4 or 5 power supplies, for instance. In the control system, it actually talks to each one of them individually, and you can see what's going on with each one individually.
Yes, you can address up to 16 power supplies, and each one communicates with central transmitter logic in order to adjust its working with the environment conditions and with the need of the transmitter.
Sure, and it also means that the power supplies are intelligently sharing the current load to the transmitter.
Yes, yes. Each power supply communicates with the other one in order to adjust its output current in order to have the same value of output current each power supply.
That's great. Okay, thank you for that. Now let's talk about the direct-to-channel digital exciter that's available. Again, there's analog exciters that are available, and there's the direct-to-channel digital exciter. Now, I have to make sure that people fully understand here. We're not talking about an analog exciter with an A to D in front of it. Or a D to A, I should say, in front of it. So it's not, what's happening here is that the entire exciter, all of its inner workings are all digital. From the input to the output, it's digital. However, this is not a digital exciter in the sense that it's creating a DRM plus or an HD radio signal. It's an exciter that's creating a conventional FM stereo signal with RDS and SCA and all that sort of thing, but it's creating it digitally. So it's a mathematical equation from the input to the output. It's truly transparent, industry-leading audio performance, and there's a wide variety of auto switching inputs, balanced analog L plus R, AES EBU, analog MPX, and my personal favorite, MPX over AES. That's really a fantastic, if you haven't used that functionality, if you've got a digital audio processor and a digital exciter, like this, you can connect them both up with a digital signal and you get rid of the extra A to D and D to A, and you end up with far better audio performance, much better peak control, so you have a much louder signal. This transmitter also has an option of internal GPS receiver which then facilitates SFN capability. Isn't that right, Antonello? I'll take that as a yes. It also has shoutcast and icecast streaming input. So it's like a backup. If your STL fails, the shoutcast and icecast streaming inputs can be programmed with the URL of the station's stream, and that can be fed direct or brought in directly and automatically in case the STL fails and goes on the air. And this is a very, very powerful backup system to your radio transmitter STL, because in most cases, studios are very reliable, and solid state FM transmitters like this are very reliable. Those STLs, whether they're IP or they're RF or whatever, can often be the weakest link in a radio station. So having shoutcast and icecast streaming inputs is a very valuable addition.
Okay, pardon, about the internal GPS,
yes.
Yes, you can directly connect an external antenna to the connector of internal GPS receiver in order to extract the reference signal 1 PPS and 10 megahertz high precision.
Right. So that means that if you can see my pointer there, I'm pointing at the GPS input connector, and up here there's the 1 PPS output and the 10 megahertz output. Is that correct?
Yes, correct.
Okay, very good. Thank you for clarifying that. Okay, so one of the main things, and we've talked about it a little bit, that the focus was to come up with the most reliable FM transmitter possible. And let's look at it this way. All the fancy features and outstanding performance are worthless if the transmitter isn't reliable. So what did you do in the development of these transmitters, Antonello, or what did your team do to assure the reliability and long life of these transmitters?
Yes, the must was low temperature everywhere. In the semiconductor, in the junctions of the semiconductor, in all the components, electrical components of the apparatus. Low temperature, and with this idea, you can obtain a long life of the transmitter.
Yeah. And one of the things we would talk about is design headroom. So design headroom in terms of temperature for sure, and that is the difference between the highest temperature of the device at the semiconductor die and the limits, but also voltages and currents and those sorts of things are also, a lot of design headroom has got to go into the design in order to get the maximum reliability.
Yes, all the components, all the circuits, voltages, current, and so on, has to be designed far away from the maximum absolute ratings. With this guideline and the guideline of low temperature, you can assure the long life of the apparatus.
Right. Right. So also, I didn't realize that there is a long list of tough industry standards for MTBF calculation, and we developed our design based and according to those industry standards. And in addition, we use thermal cameras, which we'll talk about, to maximize the performance. And another thing that I find very interesting is many companies, when they're doing their development, will have a design review where the engineers will sit around and question the design of a particular part of a circuit and say, well, should we do this or that or something else? In fact, what LNOS has done in order to assure the maximum performance and reliability and long life is we've brought in an external MTBF evaluation consultant and told them that the MTBF design target is 30 to 60 years.
Yes, yes, we used an external company to correctly evaluate the MTBF of the apparatus. We send them the design, all the informations of temperature, currents, and so on, and this external company calculated for us the MTBF.
That's wonderful. And they're using a particularly type of very sophisticated software called Isograph Reliability Workbench, which analyzes our designs with many different ways in order to assure that we're getting a valid answer in terms of the MTBF, and potentially can suggest areas that are the limitation of MTBF where we can improve the design.
Yes, one of the problem for MTBF is the on-off cycles of the transmitters.
Yep.
They alternate from hot to cold environment. You have not only a thermal stress, but a mechanical stress for the components, for the lines, for the soldering, and so on.
Right. It becomes mechanical because of the differential rate of expansion of various different types of metals.
Yes, correct.
And we're also looking with thermal imaging cameras to prove that all these calculations, all this modeling is accurate. And we can actually take the temperature of each component in a transmitter with a camera while it's operating, and while it's operating in the temperature extremes, for instance, up to 50 degrees C.
Yes, with a thermal camera, an infrared camera, we can evaluate during the development of the design and in production if we have some components in extreme thermal condition or not. And not only, but we can compare the real world, the real result of the design with the thermal simulator.
That's wonderful. That's wonderful. And I understand that we actually have an extended temperature range, not only for the operation of the transmitter, but also a range in which there's no damage to the transmitter.
Yes, we used all wide temperature range components, not only, but we have designed the apparatus with a certain type of algorithms and hardware solution in order to avoid the fault propagation and to realize a sort of thermal feedback in the apparatus. For example, varying the speed of the fans.
Mm-hmm. Mm-hmm. I understand. And I understand these transmitters will work to a much lower temperature than many other transmitters. The typical temperature range for many transmitters is 0 to 50 C. So 0 Celsius or 32 degrees Fahrenheit would be the minimum. But there are mountaintop sites, for instance, when you turn a transmitter on for the first time after being off the air for an evening, where the temperature could be substantially below 0.
It's correct. The minimum temperature for the apparatus is more or less minus 20 degrees. And the maximum temperature is more or less 55 degrees. You can use your transmitter at 55 degrees, supporting just only a reduction of the output power. For example, a 5 kilowatt can work at 55 degrees, not more at 5 kilowatt output power, but 1.5 kilowatt more or less.
So it's protecting itself. And what's interesting is the transmitter is comfortable in continuing to operate as normal or very close to normal, but if there was a technician there, he would not be happy because it's too hot, right?
Yes, yes.
Okay. So let's talk about this. It kind of rolls right into this. The life extender is a safety net. It's a set of electronic as well as, or hardware as well as software algorithms and technologies that allow the transmitter to protect itself against going off the air and or failing.
Yes, a life extender is a concept. A concept that means a lot of algorithms, hardware, that works together in order to allow to the transmitter to work in extreme conditions of temperature, reflected power, humidity, and so on. While in normal condition, the life extender is capable to make the life longer for the transmitter.
That's excellent. Thank you. Okay. Now, one of the things that's changed in the last few decades is that it used to be that engineers and technicians were at the transmitter site quite frequently, not only because the technology needed repair, but because it was the only way you could check on how things were going. But today, nobody hardly ever goes to the transmitter site. So effectively, you need to have good remote control from anywhere. And we have a user interface which works through the web and does not use Flash. It uses HTML, and you said there's a brand new language that it's being written in as well. Is that right?
Yes, that's correct.
Okay, and what's that called?
Ruby.
Ruby. Okay, thank you. And it also supports advanced, that is class 2 SNMP. And there's an optional 3G or 4G modem you can plug into this thing, and it allows you to communicate via SMS, turn on and off the transmitter, interrogate all the various things, find out what's going on via SMS, and even get SMSs when a fault is detected of any kind. You can set the alarms and alerts, and it can send you an SMS directly from the transmitter with this optional 3G and 4G modem.
Yeah,
it's wonderful. It's very, very valuable in terms of today's technology. So now let's see if we can actually go and look at the user interface live. And this is where it becomes fun, because broadcasting live. All right, so we're going to go to here, and there we have a transmitter, a 5 kilowatt ETG 5000, sitting in the LNOS factory. I'm turning it on. Hopefully you're able to see it. And eventually you'll see the power level start to creep up. And you can see here all the settings, the efficiencies being calculated. The frequency is there. You can see the temperatures on the right-hand side near the bottom. You see software revisions, the time and the date. It's after 5 o'clock there in Italy. I'm sorry about that, Antonello. Okay, so let's look at the user interface and see some of the things that we can do. One of the things that we can do is look at the digital settings in the user interface. And here we see the ability to adjust and configure the SFN. If we're using a single frequency network, we can set up the GPS, and the GPS will actually read out on the transmitter its coordinates for longitude and latitude, and then the time that's coming from the GPS. We have the RDS settings, so we can send all of the RDS settings up from this screen. And let's go to audio changeover. So this is going to show us how we can set. Right now we are configured for AES EBU audio, and it'll automatically change over to audio input left and right analog, or audio input MPX as the third priority if it doesn't find those. So we can, all the settings are here with this, and you can set up alarms for no audio. Tremendous amount of flexibility. Let's see where we actually set up the alarms here. We can come down here. I believe I've got this right. Go to profiles under events, and then we click this yellow button. And now we're seeing some of the things that we can send alerts and alarms and warnings about. So the carrier power is down 3 dB. We don't have 12 volts of DC power. The RF amplifier has a fault, on and on. We can go down here to various warnings for checksums and warnings of temperatures and those sorts of things, or we go down to the defaults, the system resets, and everything. These are things that we can configure for you so that you can understand what's going on with your transmitter. And again, these warnings and alerts can be sent by web interface, they can be sent by email, they can be sent by SMS, and that's all built right into the transmitter. Antonello, what else do you think I should show here?
Oh, you can show the hardware alarms. Do you remember?
Okay, down here at the bottom. There you go. Yeah, this is very cool. So this is graphical. You can see the combiner and at the top of the page here, you can see the status and temperature of each of the 7 PAs in this 5 kilowatt. Everything's operating normally. You can see the 3 power supplies here. They're all operating normally. You can see the PA and splitter, or the IPA and splitter, and you can see the communications from the modulator and the CPU, or from the CPU to the modulator and the CPU to the power supplies. So in this particular situation, everything is operating correctly. That's a wonderful display, and it really doesn't make any difference what language you speak. It's easy to understand. What else would you recommend?
For example, energy profile or energy cost profile under
Okay.
control center. Control
Okay.
center.
I see it. Okay.
Okay.
Let's go to energy cost profile here. So you can see here how the configuration is done in order to save money by reducing energy cost. For instance, in times when there isn't many listeners, or at times when the power company is charging a surcharge. So there's a tremendous amount of information available here. One thing I noticed that's kind of interesting, if I hold there, so this transmitter includes the 3G and 4G modem, and you can see that the signal level is pretty good for the cell site. So this is kind of something you ever see before, I think, in an FM transmitter, but it's here in this one. Anything else, Antonello, that I should mention? There's a lot. We could go on for days, but let's
we
not.
have a lot of variables, a lot of information, a complete set of information that is very long to analyze in detail.
And this will work. This will work on a cell phone as well as on a PC.
Yes, in every PC or
A smartphone.
smartphone and so on.
Yes, yes. That's not true with everybody's transmitters out there today.
You just need an internet connection.
Exactly, and a web browser, because it's not an application, it's just a web browser.
Yes, that's correct.
Okay, very good. Let's go back to the presentation and see if I can make this work. It does. One of the cool things about this now is that, the LNOS Group consists of 4 organizations: LNOS, a telco, which is a major television transmitting manufacturer located in Orvieto, Italy; Broadcast Electronics, which is celebrating this year its 60th year and is located in Quincy, Illinois; and Pro Television Technologies, which is a manufacturer of what I call RF supercomputers. These are, and we will have a whole webinar on the subject, but these are extremely, extremely sophisticated modulators that up until now have been primarily used for television, but in fact, they're capable of much, much more, but that's a subject of another webinar. And they're located in Copenhagen, Denmark. What's really cool about this is that all of the LNOS Group products from all 4 of those companies that are sold and shipped into the Americas, that's North and South and Central America, the Caribbean, all of those are sold and supported by Broadcast Electronics in Quincy, Illinois. And that's really important. So we have engineers that are trained, knowledgeable technicians at BE that can help you with these transmitters 24/7, 365, and we have spare parts stocks maintained at Broadcast Electronics. So you don't have to worry about calling far away in a different language, and we have Spanish-speaking customer service people as well. So, and if you want to talk more about this, check out our webinar next Tuesday, 1 week from today, November 5th. Note that today we're still in the United States, we're still on Eastern Daylight Time, but we are shifting this Sunday to Eastern Standard Time. Net effect of that is, if you're not in the US, the webinar will start 1 hour earlier than it started today. And my special guest next week will be Mr. Andy Barry, who's the head of BE Customer Service, and I'm really excited to talk with him about his ideas on continuing to advance the state of the art in customer service. So that brings us to pretty much the end of things. I want to take a look and see what kind of questions you all have got here. So we've got quite a lot here. Let me see if I can start to go through these here. All right. So the first question is from a gentleman who is saying he's very happy to be on the webinar. He's been working with LNOS for 5 years. He recommends them. He says, do you have an exciter that works on analog FM as a digital exciter, which includes backup audio, network decoder, and even DSP technology as a built-in component? And the answer to that is yes. We've just talked about the new direct-to-channel digital exciter, which is optional. You have choice of analog or digital exciters. And it says, does this wide AC voltage range that you've offered, this is a gentleman, Joel, all the way down to 120 volts. I love that my Nautel GV will run off a 120 volt generator in a pinch. And yes, you'll stay on the air with the LNOS ETG series of transmitters at a lower voltage. And just like your Nautel GV series, it won't run full power when you're at that low voltage, but it'll keep on the air. And that's absolutely there. And Walter is asking, I believe you're from Argentina, Walter, is asking about the SNMP protocol. Which one? We do support class 2. So we do support interrupts or traps that are supported by SNMP. It says, how does the AC to DC efficiency and MTBF of the Indium power supplies compared to the GE lineage units used by competitors? That's a good question. I think that that you'll find that the MTBF, because of the fact that we have developed these power supplies to the real world conditions in use at transmitters, I think you'll find they compare very positively. Antonello, would you like to answer anything about that? It's relative to the MTBF of the Indium's power supplies relative to the GE lineage units. Are you there, Antonello? Sounds like I'm on my own.
Yeah,
oh, there you go. Okay.
I'm reading the answer.
Okay.
And, yes, about the efficiency, the two power supplies have more or less the same efficiency. In fact, you have not to consider the maximum efficiency as a peak value, but you have to evaluate the medium efficiency in a wide range of output current and output voltage. So, for example, the LNOS power supply has more or less a 93% of efficiency over a wide range of output voltage. For example, between 30 and 45 volts, with a wide range of output current, between half of the maximum current and the maximum current. The MTBF is very, very high. The data from the field show it. I don't know, honestly, the MTBF of GE, because in this moment I cannot make a comparison between the two values.
Okay. Thank you. I'm afraid we've reached pretty much the end of things. I've got a lot more questions. I'm going to make sure that those questions are all answered by email afterwards. I'm very, very happy that everybody has taken the time to join us today. I want to thank you. I know how valuable everybody's time is, and we are honored that you chose to spend some time with us. Please do check out our upcoming webinar schedule at www.lnosgroup.com/webinar/. I want to thank my two very special guests, Mr. Antonello. I wish, sir, that my Italian was as good as your English. I'm very, very grateful for that. Thank you.
Okay, thank you to you. Thank you
And
to
to
all.
Mr. Peter Conlon, thank you so much for joining us. It's great to work with you again, my friend.
It's a pleasure doing that, Chuck. Good luck.
And for future information or further information, contact your regional LNOS sales group professional. Thank you so much, everybody, for being with us. And that's the end of our presentation. See you next week. Bye-bye.
Bye-bye.
Ciao.